called leaf disease detection. We thought of doing this project because, especially in India, where most of the people are dependent on agriculture, it is very important for them, for the crops to do well for them. They depend on their crops. Everything depends on their crop. Uh, the present way of detecting the leaf disease is through naked eyes, which takes a lot of time and effort and manpower. But that is why we thought of doing a project maybe so that we can help them in some way in making the process easier and faster. So what we used uh, this for the project is the model that we used for the project is CNN. Uh, we thought of using CNN because we went through some research papers and we got that CNN gives a touch more accuracy, maybe by a percentage or two. So we collectively came on to the decision of using CNN. So without further ado, let's let me take you through the code of what we have done. So here, these are libraries that we need to import. These are libraries and functions that we need to import to be used in the code in the process going moving forward. But before doing anything else, we need to import the functions and libraries. So what does the numpy do? What is a numpy? What does it do? It simply is used for working with arrays. Nothing else. Very simple. Now, what is pickle? Now, pickle is used to convert Python objects into byte streams because, as you know, computer doesn't understand what an image is. It doesn't understand anything. So it just knows bytes. It just understands binary. So what does pickle do is it converts Python objects into byte streams. Now, moving on to CV2, what does it do? CV2 is used to solve computer vision problems or do image processing. Simple. Moving on, list directory. It, what it does is it lists the entities that are present in a directory given by the path. Very simple. Now, these are again some more functions and libraries. I will explain all these in the code ahead. So let's move on. Now epoch, this is very important. What is epoch? Epoch 25. What does it mean? Epoch means the number of times we pass the data through the model, through the code. Now why epoch is important? Why we need epoch? I'll give you a real life example. If, for example, if you're solving a maths problem, if you do the problem once, if you solve the maths question once, it will be somewhat clear to you. But if you do the same problem 10 times, it will be the and solution will be in your head like an image. It will be so clear, it will be crystal clear, it will be in your head like an image. That is what we are trying to do here. We are passing the data, training data through the model 25 number of times so that the model learns from the data, so that it learns if a leaf is looking like this, it means it has this disease. If a leaf is looking like that, it has that disease. If a leaf is looking like this, it is healthy. So we are trying to make the model learn. Okay, simple. Moving on. BS means batch size. It is 32. It is taken as 32. Default image size is 256, which means the height and width. We need to convert everything into an array because the computer doesn't understand what an image is. Look, we have here we have provided the root, I mean the path for a directory. This is where my data set is located. This is the path to my data set. Simple. Moving on. Convert image to array. Why do we need to convert image to array? As I already said, the computer doesn't understand what an image is. It only understand digits, it only understand binary. That is why every image is converted into an array of height, width and depth. Simple, clear. Moving on. Image list. Here we have used again the list function, and here we have provided the path of the directory where my my data set is present, and what it will return is, it will return the list of the entities that are present in my directory. You will see, let me show you. Look, it is return the list of the directories that are present in my list of entities that are present in my directories. These are all the directories that are present. Moving on, this is the image size, label binary. Now, what is label binary? What label binary does is, it assigns a unique value or number to each label in a categorical feature. Okay, moving on. Pickle dump. What does pickle dump do? It helps in saving the data in the uh, saving the object, saving the data in the what is called the disk. Now, what is .pkl? .pkl is just the extension of it. Like we save Python files as .py, right? So this is a pickle file, .pkl. So simple. Here we have printed the labels. Nothing, nothing tough to understand. Simple. NumPy array, again we have converted the image into an array. Simple. Okay, coming on to the splitting part. Here we need to split the data set into two parts. That is, one is will be used for training and one will be used for the validation. What is X train? X train is the data set used for training. What is Y train? What is Y train here? Y train is the labels that are associated with the training data set. Similarly, X test is the data used for testing, and Y test means the data, means the labels that are attached to the test data. Here the test size 0.2 means 20% of the data will be used for validation, for testing, and 80% of the data is used for training. Now, what is random state? If you don't specify a fixed random state, every time you will run the code, there will be different values for the training set and the testing set. But if you specify a fixed random state, then no matter how many times you run the code, the test data and the training data will be same. Simple. Moving on. Image data generator. What does it do? It allows you to augment the image in real time, even when the model is under training. It allows you to pass random transformations to the image, to each of the image before passing it through the model. Okay, what does model sequential? What does it do? Model sequential. Model sequential, what it does is it stacks up sequential layers of the network in order of input to output. You know, we know CNN has layers. It is like a funnel. There's layers, and each layer has neurons, and there's data from in each of the neurons. All the neurons provide outputs. So this is what it is going on here. Activation. Oh, activation. What is activation? Activation is a mathematical equation that determines the output of a neural network. Dropout. What is a dropout? Dropout. What it does is it helps in preventing you overfitting. It helps in preventing from overfitting. Moving on. What is flatten? We need to, what does flatten do is, before we pass a data to the next layer, we need to flatten the data in one dimensional. All right, so this is what the flatten function does. Okay, moving on. What is dense? What does dense do? Dense layer, what it does is it takes output from all the neurons of a layer, from the previous layer, and it takes all the output and provides these outputs to all the neurons of the next layer. All these neurons will provide, each of these neurons will provide outputs for the layer that is next to it. This is what the dense layer does. So this is the layering process here that is going on. Okay, this is the model summary. I mean, how many, what type of parameters and what. how many trainable parameters, how many non-trainable parameters we have. This is what is the overall summary of the data set. The total parameters is something. This is 58 lakh something. Trainable is this much. Non-trainable is this much. Why do we have non-trainable parameters? You will ask me. So why we have non-trainable parameters is that in CNN there are layers which are hidden, and each layer there are multiple number of neurons, and each neuron has data. So when a layer goes hidden, all the neurons in it goes hidden, so we can't train those data that are present on those neurons. So this is why these 2880 number of data we can't train. Moving on, Adam is an optimizer. It helps us reducing loss and all. Okay, moving on. Okay, here we have done the epoch thing. We have done 25 epochs. These are the accuracies after each epoch. After the first epoch, we have an accuracy of 91%. The second epoch, we have an accuracy of 93%. After 25th epoch, we have an accuracy of 97.34%, which is great, I think. Okay, moving on. Um Validation. How valid our data is. Here we can see that the training accuracy is a bit more than the validation accuracy, which is normal, because let's take the example of the match question. If you have practiced the question 10 times, and if the same question appears in the exam, comes in the exam, then the probability of doing that question correctly, of you doing that question correctly, increases, right? Automatically, because you have practiced it 10 times. But if a new question comes to you, if an unseen question comes in the exam, it may be correct, it may be incorrect, you don't know, chances decreases, right? So it's very normal that the accuracy with the training data is more than the accuracy with validation data, because validation data is something that the model hasn't seen before, so it's normal. Moving on, again, the losses with training data is less than the loss with validation data. It is again obvious. If training data, if the model is performing better with the training data, because here it is clearly visible that the model is performing better with the training data, because the loss is lesser, from the validation data, because it is lesser from the validation loss. It is called overfitting. If the validation loss is less than the training data, it is called underfitting. And if they are almost identical, it is called perfect fitting. Now our model is overfitting, but after 25 epochs, it is almost identical. That is why I haven't, bothered. That is why I haven't changed anything much, because overfitting can be, corrected with the help of, by increasing epoch and increasing dropout and all. But I haven't done it because we are getting a very good percentage of accuracy data. That is why we haven't messed anything up, messed anything. So okay, let's see the accuracy. Here we have got the accuracy of 97.34%. Now we have again saved it, pickled down, saved the data in the disk as ip.pkl file. Now we have loaded the data again. Now we have loaded, yeah, so same thing, we have loaded the data set. Okay, here coming to this part, here we have provided the validation data. We have provided an input to the model to see if it gives the right data, right result or not. I'll show you. See, here it is a potato early bright, means the potato leaf has a disease named early bright. And see, our model is returning the exact value, and with a probability of 0.999, which is very high. It means our model is 0.99% sure that it is potato early bright. Okay, now we have taken a different leaf here. Now we have taken a leaf from the what? The healthy family. Let's see if our model is able to predict it or not. Let's see, let's run it. Let's run it. Okay, look, it's giving the exact result. It's showing potato healthy, and the probability of this being the right answer is 0.97, which is great. I hope now the image is clear. Now the overall picture is clear to you people of how things are working on the back end. Uh, Thank you so much.